Alright, this video is going to cover the 2.9 task. We're only going to get up to probably question 9, and 5 and 6 are going to be brief. That's going to be more of an in-class activity. That's just a little bit too much to cover in the video for the time we have. So the first thing I'm going to do is I'm going to go ahead and cover question number 1, which wants me to graph, and it's talking about giving me factored form, and it wants me to list a few things. First off, it wants me to find the axis of symmetry, and I abbreviate that as AOS. You guys know that. The vertex, it wants me to find that. It wants me to find the x-intercept, and it wants me to find the y-intercept. Before, when we did this, we would have to take this problem and we would actually multiply it. If you remember, we used the box method to do that. And then we would get x squared plus 2x minus 3. And this would only tell us, this is standard form, this only tells me the y-intercept. And then it would convert that to vertex form, which I believe was x plus 1 squared minus 4, if you do the math. So I'm doing a lot of work. I'm converting to get my vertex and a bunch of stuff. Well, we don't need to do that anymore. We can take vertex form and we can go ahead, or excuse me, we can take factored form and we can go ahead and find all this information by using factored form. Well, how do you do that, you say? Well, remember, when I look at an x-intercept, I've come out a certain number of units and I have not gone up or down. So that gives me a y value of 0. So if I have two x-intercepts on a parabola, both of these have a y value of 0. So since both of them have a y value of 0, I'm going to use that to my benefit, and I'm going to go ahead and I'm going to plug in 0 for y, x minus 1, x plus 3, and I'm going to set each of these factors equal to 0 and solve, because this is going to be one answer, this is going to be the other. Well, when I do that, I get 0 equals x minus 1 and 0 equals x plus 3. I'm going to go ahead and solve by adding 1 to both sides, so x equals 1. I'm going to subtract 3 from both sides, x equals negative 3. So this alerts me, these factors alert me as to what my x-intercepts are. If there's two factors, there's two x-intercepts. So I get 1 and 0, and I get negative 3 and 0. So I can come over here to my graph, which is what you have, and I'm going to go to negative 3 and 0, and I'm going to go to positive 1 and 0. And you say, well, that's great, but what about all my other stuff? Well, the axis of symmetry and the vertex are interlinked, if you remember. Also, these 2 points represent the left side and right side of my parabola, respectively. If they represent the right and left, parabolas are symmetrical. That axis of symmetry has to divide that parabola in half equally. So if I look at the total distance between these 2 points, the total distance is 4 units. Well, half of 4 is 2, so my axis of symmetry actually goes in the middle of those. Well, from my graph, I can look and see that that is x equals negative 1. If that's negative 1, the axis of symmetry, the x value and the vertex are the same. So I know at least one of the two values, I know x of my vertex. I just have to find out y. I know I need to go 1 unit to the left, I just don't know where up or down to go. Well, that's where we figure that out. Since I know negative 1 is an input, I'm going to plug negative 1 in for here and find out my y. So, negative 1 minus 1 times negative 1 plus 3. And just simplify. Minus 1 is minus 2 times minus 1 plus 3, which is positive 2, and that gives me a negative 4. So, my vertex is negative 1, negative 4. 1, 2, 3, 4. There's my vertex. Okay? Now, the only other thing it wants me to find, and see what little work I've shown. I really haven't shown a lot of work. These other two methods are a lot of work. Trust me, they're a lot of work. So y-intercept right here. What's my y-intercept? Well, if I know on a y-intercept, I did not move right or left, and then I moved up or down, no movement is a 0. So I'm going to plug 0 in where I plugged in negative 1. So I'm going to get 0 minus 1 times 0 plus 3, which basically is the product of these last two terms, so negative 3. So minus 1 times positive 3 gives me negative 3. And there is my y-intercept right there, which if I graphed according to my pattern, right 1, up 1, left 1, up 1, that would be part of my pattern anyway. So basically what they're showing us is there's very little work to be shown. So let me go through the second one and I'll show you. And again, I know I'm going through this kind of quick, but I don't want to make long videos. All right? If you need to, pause it. So the second one, they give you 2 times x minus 2 times x minus 6. All right, so set each factor equal to 0 and solve. So 0 equals 2. Yes, it's a factor. 0 equals x minus 2. 0 equals x minus 6. Well, this is nothing because 0 doesn't equal 2. I'm going to add 2 to both sides and add 6 to both sides. And I get x equals positive 2 and x equals positive 6. So my x-intercepts are 2 and 0, 6 and 0. So I'm going to come over here and plot those points, 2, 3, 4, 5, 6, 6. I know my axis of symmetry, and I'm going to go through this again fairly quickly, but I know my axis of symmetry goes halfway in between those points, right here. The total distance is 4, half of 4 is 2, so x equals positive 4. If x is positive 4, the x value of the vertex is positive 4. So I'm going to use that to my advantage. 2 times 4, let me just do this in a different color here. 4, make that look like a 4, not a 9, minus 2 times 4 minus 6. And all of this is going to be equal to my y. Well, 4 minus 2 is 2, 4 minus 6 is negative 2. This becomes times times times, which is 8. Is it a positive or negative 8? Positive times a positive is positive. Positive times a negative is negative. So that's negative 8. I'm going to come down here. I believe that's negative 8 right there. Now all I got to do is find my y-intercept. Well, again, the x value of a y-intercept is 0. So I'm going to use that to my advantage. So I'm going to get 2 times 0 minus 2 times 0 minus 6, which is the product of these last two terms and a. Negative 2 times negative 12 is positive, or negative 6 is positive 12. Double 12 to get 24. And that's what you would get right here. Okay? Which is going to be way up here off my graph. There's my intercept. Okay? Now let's look at the third one. And this is going to be a longer video than I want it to be, but again, you guys deserve the same out of class or in class. So you get, now you get g of x, which is minus x times x plus 4. Well, right away I know my graph should open down because it's negative. So minus x equals 0. Again, I set each factor equal to 0 and solve, right? Or 0 equals negative x. Well, even if I divide by negative 1, it's going to be 0. Okay, you can always divide by a number, but you can never divide by 0 because that's undefined. So this tells me that one of my x-intercepts is 0, 0. And what about the other one? Well, x plus 4. 0 equals x plus 4. I'm going to subtract 4. So x equals negative 4. Minus 4 and 0. There are my two x-intercepts. So 0, 0, 1, 2, 3, 4, negative 4. There's my two x-intercepts. Again, remember my graph is opening down. So I need to find that vertex. How do I determine that? Well, halfway in between. So it's going to be at what? Negative 1, negative 2. X equals negative 2. If my axis of symmetry is negative 2, my x value, my vertex, is negative 2. So now I just need to plot the y portion, and I know where my vertex is. This is where you got to be careful, okay? This actually should be in parentheses, okay? Because if it's not, you're going to get it wrong. So minus 2, because notice you have the double negative, and then you have minus 2 plus 4. So when we simplify, we get a negative times a negative, which is positive 2, minus 2 plus 4, which is positive 2 for a positive 4. 1, 2, 3, 4. Now, let's say I screwed up and made this a negative. Let's say I left this one a negative. I would have got a negative 4, which means my vertex would have been down here. Doesn't make sense. That would have told me my graph opens up, which I know my graph actually opens down. So my answer is sensible here. So I can go ahead and put that in there. And then the last thing I'm going to look for again is my y-intercept. Well, again, 0 is the x value, so just plug 0 in. I get minus, and I'm going to do this appropriately, minus 0, and I get 0 plus 4. 0 times anything is 0. So if you look at that and note about it, you don't even have to simplify anything, and you can tell that your y-intercept is 0, 0. So here's my parabola on that one. And then question 4 goes in and asks us, based on the examples, how can you use a quadratic function to determine some of the following things? Find the line of symmetry. Well, it's halfway between x-intercepts. Okay, you're going to want to write that down. Find the vertex. We're going to use the axis of symmetry value for x and solve for y. Solve for the y value of vertex. Trying to make this as short as I can. C, how do you find the x-intercepts of the parabola? You set factors equal to 0 and solve for x. I put solve for y, solve for x. D, find the y-intercept. You substitute 0 for x and solve for y. And how do you find the vertical stretch? You look at the a value. All right, so that kind of sums up what we're looking at. 5 and 6, again, like I said, are in class, and that sums up the task. All right, be sure you're asking questions and make sure you're getting your work in on time. I can't stress that enough.